Hi everyone, the problem I am going to solve in this video is one of my favorite problems on counting that also involves geometry. Here's what the problem says. What is the greatest number of regions into which a plane can be divided by n straight lines and n circles? So these are two different parts of the problem that we have to solve for. What is the greatest number of regions that n straight lines will divide a plane into and that n circles will divide a plane into. And the reason I love this problem is that it seems very hard at first, and when I actually try counting the parts, there seems to be a pattern in it that seems hard to decode, but it can actually be solved by a very elegant line of reasoning that I'm going to talk about now. But if you want, you can pause the video and take a stab at it yourself before you go forward. Okay, let's first understand, maybe with some small examples of n, what this problem involves, in terms of the solution. What do we really need to do here? So n straight lines, let me try taking a stab at this first part here, n straight lines. So if I have no line, I just have one part, which is the entire plane. But if I have one line divides the plane into two regions. So one line gives me two regions. If I draw another line, now I have four regions. So two lines will give me four regions. If I now draw a third line, how many regions do I get? So I get 1, 2, 3, 4, 5, 6 and 7. So three lines will give me 7 regions. And now I'll draw a fourth line, and because I'm trying to maximize the number of regions, I will draw the line in a way where it intersects every other line. It does not pass through the intersection point of that's already been drawn previously. So I'll draw the line in a way where it cuts every other line at a different point. So for example, if I draw my fourth line like this should give me the maximum number of regions. And now if I go about counting the number of regions starting from here, that's 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10, 11. So four lines are giving me 11 regions. So one line gives me two regions, two lines give me four regions, three lines give me seven regions, four lines give me 11 regions, and so on. So this seems to be the number of regions, or the sequence of the number of regions when it comes to straight lines. And what about circles? So let me start with one circle. So one circle will divide the plane into two regions, the inside region and the outside region. Now if I draw another circle, how many regions do I get? So I get 1, 2, 3 and the outside region, that is 4. So 4 regions in case of two circles. What if I draw a third circle now like this? So how many regions do I get now? So 1, 2, 3, 4, 5, 6, 7 and 8. So I have 8 regions with 3 circles. And now I am going to draw a fourth circle, and once again I'll draw it in a way where it does not pass through a previous intersection point, because I'm trying to maximize the number of regions that I get. So let me try and draw it like this. Okay, and yeah, you'll just have to excuse the crude drawing, but this should give you a sense. And now let's count the parts region step by step. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and the outside region 14. So I'm getting 14 regions in this case. So the sequence of regions in this case seems to be 2 with one circle, then with two circles I'm getting 4, with three circles I'm getting 8, and with 4 circles I'm getting 14, and so on. So this seems to be the sequence of the number of regions with circles. So this is the sequence of number of regions for straight lines, and this is the sequence for the number of regions with circles. But now we have to find a systematic formula where we can plug in any value of n, and it tells us what the number of regions will be if we have n lines or if we have n circles. Okay, so first I am going to solve the first part, which is n straight lines. So how do we do this? So we have to figure out a way of counting the number of regions systematically, and here's what we do. So first we draw one line and we say that for the first line we get two regions into which the plane is divided. Then we draw the next line, the second line, and then what we say is, or the way we look at this is, that the second line is intersecting the first line at one point, and this point is dividing my second line into two parts, and each of those parts is actually increasing the number of regions by 1, because this part here is increasing the number of parts in this region by 1, or increasing the number of regions here by 1, and this part of the line is increasing the number of regions here in this region by 1. So, the second line has increased the number of parts by 2. So, for 2 lines I get 2 plus 2 regions. And now we will draw a third line, and once again we will look at this third line in terms of the intersection points. So, we will say that this third line, because it is intersecting the first two lines at two different points, it is getting segmented into three parts, and each of those parts is increasing the number of regions by 1. If you look at this part here, this is increasing the number of regions by 1, because earlier we had this region here, but now because of this segment here, the number of regions has increased by 1. Similarly, this segment here will increase the number of regions by 1, and this segment here will also increase the number of regions by 1. So, the third line will increase the number of regions by 3, and we keep going. Now, I will take a fourth line and I will draw it in a way where it cuts all the previous 3 lines. So, I will draw it like this, and I will see that it intersects the previous 3 lines at 3 points. So, 1, 2 and 3, and these 3 points are segmenting the line into 4 parts, and each of those parts is increasing the number of regions by 1. This part here increases the number of regions here by 1, this part here increase the number of regions here by 1, same for this part, same for this part. So, the fourth line is increasing the number of regions by 4, and so on. So, what we find is that the nth line or the kth line increases the number of regions by k. So, the total number of regions after n lines will be 2 plus 2 plus 3 plus 4 plus 5, and this sequence continues. So, the nth line will increase the number of regions by n. So, we go up to n in this sum, and that is the sum that we have to find. Now, if I just write this 2 as not as 2 but as 1 plus 1, then what I get here is the sum of the first n natural numbers. So, that is n times n plus 1 by 2, and then I have this one here. So, I get 1 plus n plus 1 by 2, and now I can just simplify this expression to n square plus n plus 2 by 2, and that is my answer for the number of regions by n straight lines. And let us just quickly verify that this indeed gives us the correct values. So, if I put n equal to 1 into this formula, I will get 1 plus 1 plus 2 by 2. So, that is 2, correct. If I put n equal to 2, I will get 4 plus 2 plus 2, that is 8 by 2, that is 4, correct again. If I put n equal to 3, I will get 9 plus 3, 12 plus 2, 14 by 2, that is 7. So, I got 7 regions for 3 lines. So, that is correct again, and so on. So, you can see that this formula does indeed give us the correct value for the number of regions for each value of n. Okay, so that is the case for straight lines, and now we will do the case for circles, and again we will use a similar line of reasoning. So, what we will say is that the first circle gives us 2 regions. So, I will write 2 here, and again we will try to form a series for the number of regions, or the number of new regions, or the number of or the increase in the number of regions by every circle, every new circle introduced. So, the first circle gives me 2 regions. Now, if I draw another circle like this, the way to look at this new circle is that it is intersecting the first circle at 2 different points, and therefore, this second circle is being segmented into 2 arcs. So, you have this arc here and you have this arc here, and each of these 2 arcs is increasing the number of regions by 1. So, this arc here is increasing the number of regions here by 1, and this arc here is increasing the number of regions outside the original circle by 1. So, the second circle has increased the number of regions by 2, and that's why we get 2 plus 2 or 4. Now, if we keep going, let me take the third circle, which cuts the first two circles. So let me draw it like this. And now the points of intersections are 1, 2, 3, and 4. So the third circle, because it's intersecting the first two circles, we get 4 points of intersections, because there are 2 points of intersection for every circle. So 4 points of intersection, and these 4 points of intersection are segmenting this third circle into 4 arcs. So arc 1, arc 2, arc 3, and this fourth arc outside, and each of these 4 arcs is increasing the number of regions by 1. You can see that this arc here, for example, has increased the number of regions in this original region by 1. So this and this. So the number of regions has increased by 1. Similarly, every such arc will increase the number of regions by 1. So the third arc is adding 4 new regions, or increasing the number of regions by 4. And now if you keep going, if you draw the next circle that cuts all 3 of them. So let me try and draw a fourth circle that actually cuts all 3 of them. So I'm going to try and draw it like this. And how many points of intersection do we get in this case? So 1, 2, 3, 4, 5, and 6. So because the fourth circle is intersecting the previous 3 circles, it has 6 points of intersections with the previous 3 circles, and therefore it is getting segmented into 6 arcs, and each of those 6 arcs is increasing the number of regions by 1, and therefore the fourth circle is increasing the number of regions by 6. And you can now see that we have found out our series for the increase in the number of regions, and we just have to sum this to get our answer. So the nth circle will intersect the previous n minus 1 circles, and therefore the nth circle will have 2 times n minus 1 points of intersection. So the nth circle will have, because it's intersecting n minus 1 circles, it will have 2 times n minus 1 points of intersection, and therefore it will increase the number of regions by 2 times n minus 1. So our series that we need to sum is 2 plus 2 plus 4 plus 6, going all the way up to 2 times n minus 1. So how do we sum this series? Well, I can leave this 2 alone for a minute, and from this 2 here onward, so this 2 onward, I just factor out a 2 common. So I get 2 times 1 plus 2 plus 3 up till n minus 1. And now I realize that this here is nothing but the sum of the first n minus 1 natural numbers. So this will be n minus 1 times n by 2. Okay, so we'll get 2 plus 2 into n minus 1 times n by 2. So this 2 cancels out, and I get 2 plus n times n minus 1. So I can finally simplify it to n square minus n plus 2. All right, and now let's see if this is indeed correct. For n equal to 1, this gives me, if there is just one circle, this gives me 1 minus 1 plus 2. So yes, 2 regions indeed. If n is equal to 2, I'll get 4 minus 2 plus 2. So 4 regions indeed with 2 circles. If I get n equal to 3, I'll get 9 minus 3, 6 plus 2, that's 8. And yes, we did find that with 3 circles we're getting 8 regions. And so this formula seems to be correct. So for n straight lines, the number of regions, the maximum number of regions possible is n square plus n plus 2 by 2. And for n circles, the maximum number of regions possible is n square minus n plus 2. So that concludes our solution. I hope you liked the line of reasoning I used here. And if you have any other way of solving this problem, I would love to know. Let me know in the comments what you think.